Hello viewers, welcome to my channel. Today we shall be looking at a very crucial topic in mathematics, 3 by 3 matrix. That is determinant of 3 by 3 matrix. And here is the question we are to determine its determinant. Alright, so I'm using this as a mirror of this because I'll be using it to describe how to bring out the elements of each of the numbers that we'll be using at leading row of this, because we'll be taking out the rows, the first row, the number that comprises the first row, in bringing out the solution of the determinant of this particular question. So how do we go about it? So in resolution of this particular question, determinant simply represents a symbol of this form. This is the meaning of determinant of matrix A. You can see we have matrix A here, which represents this 3 by 3 matrix. That is 3 rows and 3 columns. This is the representation of determinant of this particular matrix. All right, so how do we go about it? Remember, we'll be making use of the first row, the elements in the first row, which comprises of 3, 6, and 4. So we start with 3. I'll be using this to describe how we strike out some elements here and write out the remaining part of the element for a particular number within the first row. All right, so let's start with 3. We begin with 3. And in this case, 3 represents the letter A that we have here. So how do we find the elements that comprises this particular element, A? So how we do that is that within this position of A, we strike out the rows along that and the column along the letter A. So by me looking at this, that will now mean this as the row within this particular element A, then the column along that line. You can see you strike out the elements along the position of that particular alphabet. So meaning that we'll be left out with this particular elements that we have here. That's E, F, H, I. So we use the same pattern in bringing out the elements from our major question here. So what are those elements that represent E, F, H, I? And they are 0, 6, 7, 5. We write it. Let's give space because we need a sign. I will be explaining how to get the minors and the cofactors, which is a very important aspect of solving 3 by 3 matrix, determinant of 3 by 3 matrix. So we have it this way to bring out the remaining elements, which is E, F, H, I, which represents 0, 6, 7, 5. We will need the sign that will be here, but I'll be explaining that. That means the minors and the cofactors. All right, so let's not get confused with what we are doing. Let's now proceed with the next element, which is 6. Element 6, from what we have here, simply represents letter B from here. So remember the pattern that we take. From the position of the B, we strike out the row and the column within that position of the letter we are talking about, or the element we are talking about. So for this B, this is the row that connects it, and this is the column that connects it. So what are the elements left? That is D, G, F, I. What are the numbers representing this particular element as we have it in the letter here? That is 9, 3, 6, 5. So we form another one here. That is a 9, 3, 6, 5. That is for that particular element, 6. Then we go to the next one. Now we go to the element 4. And element 4 is represented by letter C as we have it in the letter here. All right, so we strike out the row and the column within the position of the element in question. And that is This for the row and this for the column. What do we have left? That's the D, E, G, H. What are the numbers representing these alphabet? That is a 9037. So we have it here as well. 90. That is it. 9037. So these are the elements that we get when that particular position of the row 4 is considered. Now let's proceed with the next important outline here, which is the minor and the cofactors. Then another important thing we now need to look at will be the place sign. That is the sign that will be attached to each of these 2 by 2 matrix. I hope you can still remember how we were able to get these 2 by 2 matrix. That is by taking the leading row, the elements in the leading row. You can see the leading row here. That's A, B, C. In the case of the question given, that's 3, 6, and 4. So we take each one, strike out the rows and columns along the position. Then the remaining ones are being written in the form of 2 by 2 matrix, as you can see here. So what we need to do now is to find out the signs that we're going to be used here to be able to determine the determinant of this. And that is when the issue of the minor and cofactors will come in. The minor is simply the determinant of these 2 by 2 metrics that we've copied out. All right, so why the cofactors mean the product of these minors that we have and the place sign, which I will tell you how to get the signs that will be placed in each of these. Because you don't just put the sign. It is based on the position of each of these numbers of the leading row. All right, so let's start. We have this particular notation that explains this better. That is when we have a minus 1 in bracket, power I plus j. In this case, I simply represents the row, while j represents the column. All right, so let's take them one after another. We started with this, which gave rise to this. So we have to attach the number, the leading row, the element of the leading row, attached to each of these 2 by 2 metrics. This 3 gave rise to this. That means we have a 3 here. 6 gave rise to this. That means we have 6 here. 4 gave rise to this. That means we have 4 here. Then we need to determine the signs that will go into each of them. Now, how do we get this? Remember what I said concerning this particular symbol here? Minus 1 to the power I plus j. Let's make it this very simple. If you have, for example, minus 2 raised to power, let's say 2, what do you think your answer will end up to be? Minus 2 raised to power 2. That means you'll be having minus 2 times minus 2. So looking at it from here, minus multiplying minus will give us positive. That is to say, when the power is an even number, then what you are tends to have will be what? Positive. Positive and not negative. So, but if I have it like this, so your answer end up to become positive 4. Because minus times minus will give us what? Plus. And 2 multiply 2 will give us 4. But what if you now have it this way? Minus 2 raised to power 3. What now becomes the answer? Will the answer still be positive? Now let's look at it. That is minus 2 times minus 2 times minus 2. Looking at it from this perspective, minus times minus is plus. Then plus times minus will give us minus. So when it is odd number, the sign becomes negative. If the power is even number, the sign becomes positive. Now let's take a look at it from what we have. Let's start with the first one, 3 as the leading row, the element in the leading row. So we have 3 here. So what is the position of 3 in this 3 by 3 matrix? The position of 3 here is first row and first column. You can see it here, the position of 3 here is first row, first column. So in the case of this, that become 1 because that's the first row plus 1, the first column. So that will become 1 plus 1. That will give us 2. So that will be to the power 2, which is what? An even. So because it is an even, this becomes positive. Remember what I said? If it is even, the power is even, then it becomes positive. If the power is odd, then it becomes negative. Now let's take a look at the position of 6 here. The position of 6 here, 6 aligns with the first row. First, that is 1 plus, then second column, that is 2. That's making it 1 plus 2 will give us 3. So when the power is 3, what does it become? Become negative. So negative will be here. Now, going by this particular one, the position of 4 here is first row, that is 1, then third column, that is plus 4. Make no mistake about it. Let's take it again. I think we made some errors there. That is 4 is for the first row, then and third column, because this is the first column, second column, third column. So it should be first row and third column, that is 3 here. So 1 plus 3 will give us 4. So the power becomes even. So therefore, what we need to have here will be what? Positive. Recall that when it gives you even, then the power becomes positive. But when it is odd, the power becomes negative. I hope that is clear enough. All right, so having gotten the place signs of this, we are good to go in determining the determinant of this particular matrix. Now let's round it up. So to go further, we have plus 3. The way we calculate determinant of each of these, especially when you are dealing with 2 by 2 matrix, that's 2 rows, 2 columns, all right, is by multiplying the diagonals. So this is the leading diagonal and this is the second diagonal. So you take the leading diagonal first. That is by saying 0 multiply 5, 0 multiply 5, then minus 7 multiply 6, 7 multiply 6. That is for the first one. Now we move to the second one, that is minus 6. The leading diagonal is 9 multiply 5, 9 multiply 5, minus 3 multiply 6. Then the last of them all, that becomes plus 4. Leading diagonal, that's a 9 multiply 7 minus 3 multiply 0. That's exactly what we have here. All right, so going further from here, we can now conclude our calculation of the determinant. That will become plus 3. 0 multiply 5 will give us 0, minus this multiply this, that will give us 42, minus 6, that will give us 45. That's 9 multiply 5 will give us 45, minus this will give us 18, plus 4. This gives us 63. That's 9 times 7 is 63. That's a minus 0. So let's now conclude this. We have it as 3 multiply minus 42. Because 0 minus 42 will give us minus 42. Then minus 6, 45 minus 18, that will give us 27. That will give us 27 plus 4 multiply 63 minus 0 will give us 63. So now let's conclude. We have it as 3 multiplied this will give us minus 126 minus 6 multiplied this will give us 162 plus this multiplied this will give us 252. Use your calculator very well. So in conclusion, well, we now have minus 126 minus 162. That will give us, let's do the calculation here. That's 126, 162. Let's add them together. This is 8, this is 2. All right, so that will give us negative 288. Then plus 252. What would it be the final solution? Recall that you have negative 126 minus 162 will give us negative 288 plus this, that will give us negative 36. So negative 36 is the determinant of this particular matrix. I hope this is quite understandable. All right, so in our next video, we'll be talking about the inverse of 3 by 3 matrix. So that we'll be able to see how to get the place signs of other elements of 3 by 3 matrix. We just identify the place signs of the leading row because that's exactly what we're interested in this particular one. But in a subsequent video, we are going to be seeing inverse of determinant of 3 by 3 matrix, which we will need to get the place signs of each of these elements. So we leave it here for today. See you next time. Bye.